Okay, how to determine interval where function is increasing or decreasing. So we have f of x that is equal cosine square to x. Okay, so and we need to identify interval of increasing a function increasing or decreasing in the range or on the interval between 0 and 2 pi. So first step we have to take first derivative. F prime of x, it's gonna be equal derivative of cosine squared 2x, it's gonna be cosine 2x, and then derivative of 2x, it's gonna be 2, and then derivative of cosine 2x, which is gonna be negative sine 2x, and we have negative 4 cosine 2x and sine 2x. Okay, so before we identify, to be able to identify determine intervals, we need to find critical points, because then we have to go, intervals are identified by critical points. So what is going to be critical point for this cosine squared 2x? So we are taking this first derivative that we got, negative 4 cosine 2x sine 2x. We put it equals 0, and that's how we find our critical values. Okay, so we have this first derivative equals 0 only and only if either cosine 2x is equal 0 or sine 2x is equal 0. Okay, so let's find a point where cosine 2x is going to be 0. First of all, we know that the period for the cosine x, in this case it's going to be 2x, right? The period is 2x has period 2 pi, right? Which means for x, in this case, because we have cosine 2x, or this 2x meaning that two waves is going to fit in one period. So I'm going to graph in a minute. So here we have the period of the cosine for x of this cosine is going to be 1 pi. Okay, let me graph this cosine to x so we can see how it works. I would start with graphing cosine x. Okay, so let me see, this is our half a pi. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this point, it's going to be here. This is pi. 1, 2, 3, 4, 5. This is going to be 3 over 2 pi. Um, 1, 2, 3, 4, 5. And this is going to be our 2 pi. So the graph is going to go like this. Okay, not bad, not bad. Okay, now let's, so since for the regular cosine x, the period is 2 pi, but for our cosine 2x, the period is going to be 1 pi. So let's squeeze in, let's see what we're going to get. So it's going to start same way, right here, and then so practically everything is going to be divided by 2, right? It's going to be less by 2. So pi over 2 is going to become pi over 4. It's going to come here, and then this point will come here, here. Okay, let me try. All right. So we have here, so we have in the black color, which is cosine x. It's fitting one wave, right? In one period. This fits one wave. But for the graph cosine equal cosine 2x, it's supposed to fit two waves. Let's check. This from here to here, it's one wave. And then from here, we are coming down all the way, comes here. This is another wave. Okay, so we fit in two waves because we have cosine. This cosine 2x. The coordinate of x shows how many waves will fit in one period, 2 pi. Or 1 pi, it's gonna be twice, the period gonna be twice as shorter because you have two waves in 1 pi. So the wave is gonna be twice shorter, what's gonna be 1 pi, right? All right, so the points where a function is equals 0, where y is equals 0, this is what we call critical points. These points, let me mark down like this so you can see. Those are our critical points, and that's what gonna identify intervals. So let's see what we're gonna do. Okay, this point is pi over 2. This is gonna be the 1 pi. Here we have 3 over 2 pi. And finally we have 2 pi. Here we have 2 pi. Okay, how much is well, we know that period is 2 pi for the cosine x, and which means from here to, from this point, from half a pi to 3 over 2 pi, it's gonna be 1 pi, right? So which means for cosine 2 pi, it's gonna be half a pi, correct? Because everything is splitting, the cosine 2x. So based on that, we are going to figure out the critical points. Let's see. Here we have cosine x, and here we have cosine 2x. Okay, critical point for cosine x is pi over 2, right? Pi over 2, which for cosine 2x will become pi over 4, right? Because just like period, we divided by 2. Oops, pi over 4. The same way here, every single critical point for cosine x it's going to be for cosine 2x, it's going to be twice as less, right? Okay, next critical point we have, it's going to be here 3 over 2 pi on the cosine x. This one, 3 over 2 pi. Which for the cosine 2x, it's going to be 3 pi over 4. Why? 3 over 2 pi divided by 2, we get 3 pi over 4. Next, for the cosine x, it's going to be 5 pi over 2. How did I figure out that it's going to be 5 pi over 2? Very easy. The critical points are located on 1 pi distance. See that? This is 1 pi distance. So therefore, every time I will add 1 pi, which means for cosine 2x, it's going to be adding half a pi, right? So you either identify critical points of cosine x and divide by 2, or you go by half a pi, add half a pi. Let me see. Add half a pi, okay? So let's add another half a pi, and we have to watch that we are working within interval 0 and 2 pi. So we can't pass 2 pi, right? Okay, so 3 pi over 4, 3 pi over 4, which is I put 3/4 of pi, and plus pi over 2, 1/2 of pi. That is equal 3/4 plus 1/2 and this pi. So it's going to be equal 3 plus 2 pi, right? So this is going to be 5 over 4 pi. So I'm not going to write down, continue this cosine x. I'm just going to follow this cosine 2x all the way. So next 5 over 4 pi plus another half a pi. And we are going to get 5 over 4 plus 1/2, right, of pi. It's going to be 4, 5 plus 2. So it's going to be 7 over 4 pi. If I add another half a pi, I will go behind of 2 pi, okay? Therefore, I'm stopping there for cosine 2x. Critical point for cosine 2x. Okay. So we have practically pi over 4, 3 pi, 5 pi over 4, and 7 over 4 pi. Now we need to identify critical points for sine 2x. Critical point for sine 2x. Here it is, right? Sine 2x we have. In the same way, because for these 2 sine x, usually it has the period 2 pi, but we have 2x the period with period 2 pi, which means period for x is going to be only pi, right? All right. So let's find the critical points for sine 2x. So I will have here sine x, and here I will have sine 2x. Okay, let's build this graph here. All right, 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. This is half a pi. And this is going to be our positive one. 1, 2, 3, 4, 5. 3, 4, 5. This is our negative one. Okay, this is half a pi, and then 1, 2, 3, 4, 5. This is going to be pi. 1, 2, 3, 4, 5. This is going to be 2 pi. No, this is going to be our 3 over 2 pi. And then 1, 2, 3, 4, 5. Here we get 2 pi. Okay, let's see how we're going to build this. At the point of half a pi, it's going up. And then we have it. So, which means this is our sine x. Now let's build cosine x. So it's 2.5. It's gonna come here. And okay, let's see. Gonna come here and then come down here where pi is. The opposite face, right? It's too much. I went wrong. Okay, something like this. Use your imagination. So within one period, it's going to fit 2 waves, okay? Because we have sine 2x. That's what coefficient means, the meaning of that coefficient, 2 waves. If it would be a half x, that's mean in the period 2 pi would fit half of the wave, right? Okay, something like this. Let me fix this one also, and we move on. Okay, well, not bad. All right, so our critical points on, start from x. Our critical point is going to be pi, right? And 2 pi. So, which means this is our half a pi. Okay? So, which means if for sine x, critical point, it's going to be 1 pi. Then for sine 2x, it's going to be twice as less, right? It's going to be pi over 2. And then for 2 pi, sine 2x is going to be divided by 2. It's going to be 1 pi, right? Right here, pi over 2. Here we have, for this one, it's going to be 1 pi, right? Okay. And since sine x, it's going from critical value to critical, from critical point to critical point, it goes through 1 pi, half a period. It's right here. Then for the sine 2x, it's going to go pi over 2 period, right? Sine 2x. Okay, so we have here will go by 1 pi, 3 pi, and for a sine 2x is going to be 3 pi over 2. You can't go further because you will pass 2 pi, right? If I add 3 over 2 pi, if you can see it's moving through half a pi, right? From here to here, it's a plus half a pi. From here to here, plus half a pi. Now, look, if I 3 over the 2 pi plus half a pi, it's going to be 3 over 2 plus 1 over 2, right? So it's going to be 4 over 2. We are getting 2 pi. And we cannot 4 over 2, so it's 2 pi. And we are not interested in 2 pi because our interval between 0 and 2 pi is not included. Okay? All right. Let me clean this. And now once we identified our critical point, let me write down our critical point is pi over 4. Let me write down this way. Pi over 4. And then second one, I will put pi over 2 because from sine to x. So I'm just putting in order. Okay. Then it's going to be 3 pi. Well, okay, not to confuse you, I'll just put first critical point for cosine and then critical point for sine. Pi over 4, 3 pi over 4, and then 5 pi over 4, and 7 pi over 4. And then we are moving to critical point of sine. It's going to be sine 2x. It's going to be pi over 2. And it's going to be pi. And then 3 pi over 2. Okay. Now it's time to determine the interval where graph or function is increasing or decreasing. Okay. So what was our first derivative? It was f prime is equal negative 4 cosine 2x and sine x. Yes, I'm going to do here some changes. F prime is equal negative 2 times 2 cosine 2x sine 2x. And this is, remember this formula? This is going to be sine 4x, double angle, right? It's going to be sine 4x. So we have f prime is equal negative 2 sine 4x. Okay. So let's start figuring out the intervals and sign of derivative on that interval. If the derivative is positive, then the graph is increasing on that interval. If derivative is negative, then graph is decreasing on that interval. So first of all, let's line up these critical points by in ascending order so we can build these intervals. And it is going to be pi over 4. Next is going to be pi over 2. And then it's going to be 3 pi over 4. And then pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. Okay, now let's test the intervals and find out if the graph on the given interval is increasing or decreasing. We start with the first interval that ends with pi over 4. So we write down here x is greater than 0. Let me make it thicker. X is greater than 0, less than pi over 4. So in this case, what do we take? We can take less than pi over 4. We take pi over 6, 30 degrees. Okay, so we have, I'm going to do drafting here. Let's see, negative 2 sine for x. And if I take pi over 6, it's going to be equal negative 2 sine 4 times pi over 6. So this is 2, this is 3. So it's going to be what? Negative 2 sine 2 pi over 3. 2 pi over 3 sine, it's square root 3 over 2. So it's going to be square root 3 over 2. It's gone, and we get negative square 3, right? Square root of 3, which means if it's negative, that means we are getting here f prime of x is less than 0. So conclusion is going to be decreasing. Oh. All right. Next one. So what is our next interval? X is greater than pi over 4 and less than pi over 2. Pi over 4 and less than pi over 2. Okay, so pi over 4 and pi over 2. Let's take pi over 3, huh? We take pi over 3 this time, 60 degrees. So we will have here four times pi over 3. And the sine of 4 pi over 3 is negative square root 3 over 2. And times negative 2. Now result is not interesting. What is interesting, we are getting plus sine. And that means f prime of x is greater than 0, which means the function is increasing. Okay. Next interval, it's going to be between pi over 2 and 3 pi over 4. So x is greater pi over 2 and less than 3 pi over 4. Okay, so let's see, 3 pi over 4. Let me take 2 pi over 3. Okay, and here I have 2 pi over 3. Now let's figure out how much it's gonna be. So let's do drafting here. 8 pi over 3. Let me convert into mixed fraction. 8 pi over 3. That is 2 and 2/3 of pi, right? So which means this is, if I take off 2 pi, go down by 2 pi, 360, I'm getting 2 pi over 3, right? So which means in this case I will have sine 2 pi over 3, which is going to be 2 pi over 3, it's 120 degrees. The sine of it is square root 3 over 2. So we are getting negative 2 times square root 3 over 2, which means the answer is getting negative, which means f prime of x is less than 0, which means we have here decreasing interval. The graph is decreasing. Okay. I will do one more and the rest I'll just fill out the table. So I'm taking between 3/4 of the 3/4 of pi and less than pi. Okay. So what we're gonna take this time, let me clean this. Drafting. So 3/4 of pi and 1 pi. Let's take 5 pi over 6. 5 pi over 6, it's 150 degrees. And indeed, it's between 3/4 of pi is 135 and pi is 180. So I'm taking 150 degrees, which is going to be 5 pi over 6. Okay, so sine 4 times 5 pi over 6. Let's reduce, this is 2, this is 3, and we are getting, let's do drafting, 10 over 3 pi. All right, so 10 over 3, it's going to be equal 3 and 1/3 of pi, correct? Okay, if I take off 2 pi, right, one period, 360 degrees, I'm going to get 1 and 1/3 of pi, which is going to be equal 4 over 3 pi. So sine, so we have negative 2 times sine of 4 pi over 3, it's going to be negative square root 3 over 2, which will end up with plus. And that means our derivative is positive and the function is increasing. Okay, I solved step by step 4 intervals. The rest I'm going just to fill out. You can continue practicing on your own. So what do we have now? We have x is greater than pi and less than 5 pi over 4. And here we are going to have function graph is decreasing. Okay. And we have now, what else left? 5 pi over 4. And 3 pi over 2. So 3 pi over 2 here is increasing. And we have 2 more. Let me move this down so you can see. I can clean this. And actually this also. Not to leave the drafting. And move this down so we can see. And we have now, wait a minute, did I do all of them? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. No, I didn't do all of them. Okay, so I have between 3 pi over 2 and 7 pi over 4. 3 pi over 2, 7 pi over 4. Okay, and on this interval we have f prime of x is decreasing, and the last interval it's going to be between 7 pi over 4 and 2 pi. Okay, and here we will have increasing f prime of x is increasing, and the conclusion is increasing. Okay, there we go. So we have the table here. So you can see that where a graph is increasing. So let me mark down. Graph is increasing here, 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 here. And graph is decreasing here, here, this interval, and this interval. Okay, so what does that mean? I would like to find also relative maxima and relative minima. So what is going to be our relative maxima? Let me write down. We are getting relative maxima when it's from increasing, when graph from increasing to decreasing, from increasing switching to decreasing, we are getting relative maxima. And when graph is from decreasing switching to increasing, here decreasing switching to increasing, then we are getting relative minima. Okay. Now let's find the interval where from when the graph is switching from f prime less than 0 to f prime greater than 0, then we are dealing with minima. And if the opposite, if from greater than 0 switching to less than 0, we are dealing with relative maxima. Okay. For relative maxima, we are going to have point, half a pi, and 1, because sine at the point half a pi is 1, right? And that's where here it is. It was from maximum, right? From increasing, moving to decreasing. So it's a maxima, relative maxima. Next, we have pi 1. Pi and 1. If you plug pi, result is going to be 1. And then we have 3 pi over 2 and 1. Those are coordinates of maxima. Okay. Now coordinate of minima is going to be pi over 4. Pi over 4 because it's switching from decreasing to increasing at the point of pi over 4. So we are getting pi over 4 and 0, and then we can have 3 pi over 4, 0. 3 pi over 4, it's from decreasing to increasing. Then we have 5 pi over 4, comma 0, and lastly 7 pi over 4, comma 0. Okay, so this is what we have done, and I hope it was interesting and it was clear. If not, then you can ask questions in the comments and I'll gladly answer all your questions. Okie dokie.